Oh wait, no, this is actually another chart. Hold on. I wrote this down somewhere, but if it's not on here, yeah, the first question is not that. It's something else. It's like this stuff. There we go.
Oh,
Yeah, this is also what we need for question 15. All right, now we can come back down. Sorry about that. Section. There you go. All right, 15. Timer restarting 4 minutes and 13 seconds. Oh, and that's time. Anyone need more time?
I'm done, I think.
Anyone else? Time? You said what?
All good here.
I'm sorry, I can't hear what your mic is. Your mic's kind of.
Echo. Yeah.
It might be I have my face mask on.
Oh yeah, that sounds better.
Yeah, it said all good here. So
Okay, cool.
Okay.
All right, so then actually, yeah, no, it's fine. I'll get to explaining. So I'll put down my answers first. So for A, I got. All right, so thumbs up, thumbs down.
Okay.
And even if you got the same answer, if you need me to explain like how I got to that answer, if you're not sure, you just kind of like knew a formula or something, just let me know, and then I'll like bust out a whiteboard or something. For B, I got. Oh, I see a bunch of people typing. We'll wait. Yeah, I'll email him real quick. Just ask him.
Tech Snipe, he did say he would, but I don't know. I'm not sure.
Oh fuck, what's his email?
Wait, I don't know if this is an answer, but is he going to provide the rules with inference and stuff for
I'm
tomorrow
gonna email
for
him
the
right now.
exam?
I'm gonna email him.
Yeah, because I don't know them all of them by the top of my head. So if I need to know them by tomorrow, I need to know.
Yeah, I don't think anyone knows them off the top of their head. Not even him, because it's like, why would you just look them on Google?
I mean, yeah, I would hope that he thinks that. I hope so.
Hopefully, bro. For being taught by a human being, then shouldn't be questioned. But that'll all be found out tomorrow, won't it?
Oh, Lotus wants an explanation, by the way.
All right, cool. All right, let me finish this then. What's his last name? Is it Tio or Ka? I just keep on getting them mixed up.
I think
I'm gonna just say Tio. It's whatever. It's a Tio.
let me check on the syllabus. I mean, Kayateo. Is that how you say it? I probably butchered it.
Mr. T.
Not Mr. T.
All right, cool. All right, I emote him. All right, explanation. All right, hold on. Let me switch because I'm only streaming my thing right now. Just share the whole monitor on your foot. Don't pull my IP, please. All right, cool. Uh, wait, let me get my drawing tablet. Let me get this shit in a minute. I'm gonna go full professor, bro.
And she teaches this class, bro.
All right. What? I can't use this shit online. What? No, Microsoft Whiteboard. Oh shit! I don't want to download it. I just use OneNote. I mean, fuck. Okay.
Yes, sorry, one yeah.
All right. I don't even notebook for this class. Yes, I do. All right. So, what was our question again? It was what's it called? So all students in this class understand logic, right? So that's our first statement. It's a big one. Every sentence counts, right? Yeah. So we're gonna say that our insert or draw. Oops. Oh fuck. Oh well. We're gonna say that q of x is equal to shit. X is in this class, right? So x in class. Actually, hold on, guys. Give me 1 second. I need to set up this drawing tablet. It's on the wrong monitor.
Fine.
I don't want to draw with my pencil. One second. How do I do that again? All right, here we go. Mapping monitor 2. All right, there she is. All right, cool. All right, so q of x, x is in class. I don't know what the class is called, right? And then p of x is going to be, what was it again? They know logic, right? Yeah. So x understands logic.
Yeah.
Yeah, logic. So first thing we're going to look at is the second sentence. And it says Xavier is a student in this class. So with that sentence, you're going to have to look at the Mojis, under the universal instantiation stuff. So what is it? So if for all x's, something x, so just sx is true, therefore S of C is true with C being like a specific case. Same thing with like N and K, where N is like the general variable and K is the like, this is a number, but like it can be any number. So we're using a letter instead, type B. So for all X, S of X is true. Therefore, for one specific case, S is also true. So we come back up here and in our sentence, it tells us, all right, cool. So we have our guy Xavier who is in this class. So our A of X, we can say A of X, and he's in this class, so we can use Q here. Because this is the first sentence. And then our second sentence is this, what's it called? Q of C, and then C equals Xavier. So then, now that we know that that's true, we can come back over to, what's it called? Our Mojis ponens, or look at the last sentence first. So, the last sentence is what we're proving. So therefore, Xavier understands logic. So that's what we're proving, right? So since we know for sure that Q of C is true by, what's it called? Universal instantiation, we can now say that, all right, Q of C, C being Xavier, and then what's it called? Based on our first sentence, if you are, I keep on getting it backed up. All students in this class. So if you're in the class, you understand logic. There we go. So erase this. And then it says, if you're in the class, then you understand logic. So therefore, by Mojis ponens, the perfect formula, you can say P of C. And then P is X understands logic. That's how this works.
Okay.
Stuff like that. Yeah. So, and then with the second one, it's basically the same thing. It's only that they fucked it up. And that's why it's false. So you're going to have what every computer scientist takes discrete math. So let me get rid of all this. Oh, you probably should have taken a picture of that first. Hold on. If you need a snip, just take a quick snip and then I'll move on. If you're good, just let me know. I'll give you like 10 seconds. All right, cool. So you got the snip. Let me get rid of all this. I like how it erases by stroke, but it's also inefficient for getting rid of a lot of shit. I guess I could just use lasso select. That's better for next time. All right, cool. So our next one was computer science and discrete math, right? So computer science major takes discrete math. So that's the first sentence. So for all x, if you're in discrete math, no, if you're in computer science, then you are in discrete math, right? So that's what it gives us. And then our next sentence is Natasha is taking discrete math, so D of C. So our formula is going to look like C of x infers D of x. And now, oh fuck, eraser. And now we have D of x. But the problem with this is that if you look back up on our formula, if we say that C, oh shit, I dropped my pen. Sorry. If we say that C is our P because it's before the arrow, and D is our Q because it's after the arrow, D is our Q, the formula says P infers Q and P is true, therefore Q, but this is P infers Q and Q is true. Well, I don't know about y'all, but I don't see that anywhere. I see if Q is false, but Q isn't false. They just told us that Q is true, so this therefore doesn't work, and the statement is false.
Okay. Yeah, because I got this wrong. I didn't quite understand because like it made sense to me that it was false, but I put true anyways because I thought it was like every student that takes discrete math, I guess would I don't know. I don't know what I was thinking.
Yeah, that's why I was like, you don't need me to explain, because like when you think about it intuitively, it makes sense. Like I can say I'm in computer science, I'm taking discrete math, she's taking discrete math, but like you could be a fucking math major taking discrete math. You know what I mean? Like you don't have to be in computer science. Like when
Yeah.
you think about it logically, but then you have to realize that you have to write this shit down because that's what the point of the class is, writing down the logic. So, but yeah, for the most part, you can just use these formulas and shit. And then for C, it's pretty much the same thing. So you would have oh yeah, hold on. Lasso select, delete. Oh, this one. So if we have what's it called? Parrots and fruit, right? So all parrots like fruit. So let me write this down. So P of x, x is parrot. Sorry for the shit handling right away. F of x equals x likes fruit. Right. Wait, well, hold on. I just do this. I'm retarded. All right, there we go. That's a lot better. Kinda. You don't need as much space. All right, so f of x is likes fruit. So our first sentence is, oh, what the fuck? That's the wrong question.
Maxwell, could you mute?
Oh yeah, Max. All right, there you go.
Thanks.
All right, cool. So C of x, so our first sentence is all parrots like fruit. Oh, I'm not on the drawing. So for A of x, P of x implies f of x. Oh, wait, no, that's cap. It's and. This is and now. And then what's it called? My pet bird is not a parrot. So not P. Fuck. Undo. Not P of C. So we have P. So this is our. Oh, hold on. Let's look at this formula. So. Oh yeah, no. There's no formula. So yeah, there's nothing that has P and Q, and then not P. So since there's no formula, this is a false statement. And then once again, you think about it intuitively. No, it's like he doesn't have to be a parent to like fruit. You can be like a fucking bear or some shit and still like fruit. You know what I mean? So that's the logic behind that too. I think even if you were to put this as infers, because this is P, not Q, so it doesn't really matter. I'm pretty sure it's and though. So because all parrots like fruit. Yeah, that was what it was on the first. So yeah, that should be and. So yeah, that statement is also false. And then for the last one, delete. For the last one, we have everyone who eats granolas every day is healthy. So we have g of x equals x eats granula, and then healthy So our first sentence is A of x, g of x implies h of x. And our second statement is Linda is not healthy, so not h of c. Is that a formula?
So,
It
inverse-
is modulus tonans. We have p. What is it? G of c, right? Oh no, not g of c. And what is it saying? Therefore, Linda does not eat granola everywhere. Yep, I guess the true statement.
Wait, wouldn't that be what's it called?
I have a feeling I'm going to assume what you're going to say is when you think about it, that's not true, right?
Yeah.
But you need to understand that we're suspending belief for this question. So in this question, they told us explicitly if you eat granolas, you are healthy. That's the only way. I don't give a fuck how much you work out. I don't give a fuck how much water you drink. The only way to be healthy is to eat granola. That's what the question is telling us. That is a true statement. So that's what you have to go off of instead of reality. Like reality doesn't apply because they're giving us the reality. They're telling us the truth, and we have to go off of that.
No, I was thinking more along the
Oh.
lines of P implies Q, and then the inverse of Q.
Yeah, so that's modulus tonans.
Oh, okay.
Yeah, that's why. So that's why this is a true statement. Because our P is G, so this is P,
P.
and then yeah, this is Q, and then this is not Q, so this is not P, which checks out. So
Okay.
our fuck P. There you go. So true statement. In this world, in the world of question 15, part D, where the only way to be healthy is to eat granola bars, it is a true statement.
Oh, Max was saying C is not correct.
Wait,
Oh,
is
is
C
it?
not correct?
What? Yeah.
Oh
C.
wait, yeah,
What
we
did
can
the
check our
answer say?
answers.
Yeah.
Wait,
Because,
not
like, you
correct
can
as
have
in not true, or what I got was wrong?
as in, like, the statement is not correct, right?
Yeah, that's
Yeah.
true.
Is
Yeah,
incorrect.
that's the right
Okay,
answer.
cool.
Yeah,
Yeah, that's what I
yeah.
meant. Yeah, that's what I
So
meant.
yeah, A is true, B is false, C is false, D is true.
Perfect. Yeah, same page.
Yeah,
Okay.
there you go. And then yeah, let's check our answers, because I might just be talking out my ass. I'll put shit down.
I thought I was wrong for all of them, but I was only wrong for 2 of them because I put true for all of them.
1.4 answers. Was that 15? Oh wait, no, this is 1.4 anymore. This is 1.6. So we are behind. Don't worry, I'll zoom in. Full screen this. 1.6 question 15. So yeah, A is true, B false, C false, D true. There you go.
Hey, that's what's up.
Anyone need me to
Hopefully
zoom
we
in?
can
Or-
add something like that on the exam.
Yeah,
Yeah.
yeah. Universal instantiation in most totals. Instantiation watches ponens. Invalid because there's no formula. C invalid because there's no formula. I actually don't know how they got to these reasonings using false. I don't know how else to explain it that it's not a formula because that's really all you have to do. See if it's a formula. So, but whatever.
Mm.
Yeah. So everyone see how we got 15. What's it called? Who asked the question? Lotus, are you good? Does it make sense? All right, cool. All right. So that's that. So oh fuck, I came up with the wrong thing. So now we are going to go back. Let's see if there's another question in 1.6 that can tick our bones. Oy, 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 oy. Oh, that's long. I don't want to do that. Determine whether each of these arguments is valid. If an argument is correct, what rule of inference is being true? If not, what logical error occurs? True number system n is greater than 1.
We could do just one of those if you think those are good questions.
Yeah, so I'm reading it to see if it's a good question. It's pretty much the same thing as what we did, just with math instead of words. So n is a real number such that n is greater than 1. N squared. Well, that's false. Oh, wait, no, I'm capping. Never mind. It's not greater than or equal to. But I don't really know. Oh, yeah.
Lotus, which homework are you talking about? Question 9 of the homework. Oh, the first homework, question 9, where they gave us 2 premises. And leads to a conclusion. Okay.
Trying to see. I think he wants to find one on here. I'm trying to find one, but I don't see one. I think another one would be 10, but we're not going to get the answer to that, so you're just going to have to be good.
You want to just try doing number 9? Like the actual question.
Oh wait, no, yeah, we were doing 15. My bad. We're doing think we were doing 9. Yeah, so 16. There we go. I think this is another one. We should determine whether the argument is simple. Yeah, okay. So 16 then. But we're not going to be able to check the answer, but I think we should know which direction we're going to go. So 16 for everyone. We're going to do, what's it called? 5 minutes. Or let's do 6 minutes, actually. Actually, let's do 5 because I explained it now. So
we're doing 16, right? I thought we were only doing odd numbers, or I guess it doesn't matter.
I only did odd numbers because I wanted to check my answer. And since we're on the right track, we can do 16 now, and then I can be certain that I'm giving you the right answer.
Makes sense.
All right. So yeah, 16 is literally just a copy of 15 with different questions, but you just can't check the answer for it anymore. So that's what it's for. So hold on, let me do this. Okay. Starting timer now. No, 16. Sorry. That's on the wrong monitor. Perfect. That's time. Anyone else need more? Am I muted? Oh no, never mind. Okay. Anyone need more time?
I'm good for now.
Yeah, I think once you've got the general concept, you don't really need to do all of them. Oh yeah, I'm typing study room chat by the way, because that's the only place I'm looking at right now. All right. So I'm gonna assume everyone here is good. Does y'all need me to write it down again? It's literally the same thing as last time, just different letters and words. Yeah. If y'all want to thumbs that or down, up or down, y'all can do that.
I was kind of confused on the last two. Yeah.
On the last two, all right. I didn't do those, so we can do it together, and then someone can tell me if I just did it completely wrong too. All right. So C and D.
Mhm.
Let's do those. Okay.
Just like a quick explanation for me, at least for part C. If it only said Quincy only likes action movies, it would have been true. But it says that likes all action movies. So he might like other movies as well, not only action movies. So that's why I think that's why it's incorrect. We cannot assume that Eight Men Out is an action movie.
I guess. I don't know. I guess that makes sense. So
All right. Yeah. Let me add on to that. See if I can, and let's compare and contrast. Well, mapping's on the wrong monitor again. I'm gonna love switching between these two. I should make that a button actually. It'd be really cool if I could. Let's do fuck redo. Too hard. Okay, never mind. So for our question C, we're gonna have Quincy likes all action movies. All right. So what's it called? So let's see. A of X equal to X likes action. I'm pretty sure this one's going to use something completely different thing. Can someone pin the truth tables by the way, so I don't have to keep on scrolling back up?
Okay.
All right, so X likes action, and our first sentence is Quincy likes all action movies. For I guess we can also do Q of X. Quincy. What the fuck? Oh, undo. Damn it. Okay. Oops. Well, undo that. Undo that. Undo. There we go. Okay. Quincy likes X. Oh, well, we don't need this. Yeah, we'll say Quincy likes action movie X for that. So we have for A of X, Q of X. That's our first sentence. Quincy likes the movie, so 8 Men Out, so Q of C. Therefore, 8 Men Out is an action movie. Okay, wait. So this is universal instantiation, right? Yeah. So we have that, and then Quincy likes. No, I don't.
Yeah, that's what I didn't get either.
Yeah, no. I mean, looking at it, I mean, there really isn't anything else you can do from this because this is really just this first part that I read is just the universal instantiation. So this is the first thing that they give us. This is sentence 1. And then Quincy likes the movie Amen Out. Nah, yeah, there's nothing you can do with that, yeah. P and Q, but we don't have a Q. This is just our P. Yeah, I think it's false.
I did it was I had P where I guess that's wrong because I had P become Q. Quincy likes movies, and then all movies are action movies.
Wait, you did what?
So I did it the way Quincy likes all movies, and then that implies that all movies are action movies. And
If it's not explicitly stated, then you should just go off of real life, which that statement is false, so you can't run with it.
okay,
Yeah, that's why. Yeah, the only thing they tell us is that Quincy likes all action movies. Whenever you see all or A,
Mhm.
immediately think of A of X or E of X.
yeah,
Immediately think of that. So you're gonna say, okay, so he likes action movies, and I saw an all over there, so that's gonna mean there's gonna be an A of X somewhere, and then the normal statement.
okay,
So that's usually how you want to think of it whenever you're building your functions, or I don't remember what they're called, projections, predicates.
predicates, yeah.
So yeah, so A of X, Q of X implies Q of C. That's true. That's a universal instantiation. But this conclusion just like came out of nowhere. Like I have no idea where they got that. So it's a false statement. So C is false. And then for D, for the Dizzle,
Yeah,
we
for
have
D, I had false, but
false. All right.
Max said correct. Max said it's right. So bit of contention.
So let's say L of X. X is a lob man. And then what's it called? D of X equals X sets 12 traps. Let's just say a dozen so I don't confuse you guys. A dozen is 12.
Mhm.
So our first sentence says all lobstermen set at least a dozen traps. So we have A of X, and then if you are a lobster man, then you set at least a dozen traps. Cool. So that's sentence 1. Hamilton is a lobster man. All right, so we have L of C. Therefore, Hamilton sets at least a dozen traps. D of C. Pretty sure this is the formula, right? Yeah, that's modus ponens. This is a true statement.
Okay. I guess
Yeah.
that's I guess the thing I'm getting confused on is the order. Like in
This is
mod
usually the hardest part, just being able to set up the predicate.
yeah, no, I'm confused on the order of the when you set it up. After you set it up, you like you have the implication first and then just the letter by itself.
Yeah, I'm just going based off of the sentences. That's what the
Yeah,
point
yeah.
of the last chapter was. Is just like so you can learn how to translate English into what's it called formulas, so that you can do shit like this, so that you can set up your equations and then compare it to your formula, see if it works or not.
Okay.
Yeah.
I'm
So literally, like that's all it is. Like this is literally sentence 1. It says all lobstermen
Yeah.
set at least a dozen traps. So if you're a lobsterman, you set a dozen trap, and this is true for anyone who is a lobsterman. Stuff like that. And then C is our specific case, being Hamilton. So C is Hamilton's a lobsterman. So L of C,
Yeah.
and then D of C. The reason why I'm jumping between X and C's is because I'm not using the modus ponens step or the universal instantiation step. Because
Mhm.
like feel like having it's two separate parts just makes it more confusing.
Yeah,
And you can
yeah.
just look at it like this, and then you know that this is what's it called ponens, because it's like A of X of some statement implies another statement, which this is the implied statement, and then you can just have it set up all automatically.
Okay.
But yeah, you should know though that this was both universal instantiation and modus ponens.
Yeah.
It was both.
Yeah, I get you. Appreciate it.
Yeah.
Funkster saying I think that's how you say it, but he's saying he's confused on B.
On Bizzle? All right, let's get Bizzle then. Oops. L.
That's
Give me a
okay.
second. Exam 1 review. Okay, so for B, let's do this together. So a convertible car is fun to drive. So we have C of X equals X is a convertible. And then we have F of X. X is fun to drive. So our first sentence says a convertible car is fun to drive. So for E of X, I think it's C of X and F of X. And then Isaac's. Actually, let's do the universal stuff first. Let's make sure we get that out of the way and know what we're talking about. So, hold on. I gotta bust this open again. All right. So, all right, this is existential. So, because we're dealing with E of X now. So we have E of X, P of C. So, B. All right. Isaac's car is not a convertible.
So the reason you put existential is because they're talking about a specific car, right?
Yeah, universal is for A of X and existential is for E of X, but they're both the same thing. The only difference is instantiation and generalization, and then between universal and existential is just A of X or E of X.
Mm-hmm. Yeah.
There you go.
Nah, I think
So
for the wording. So
verbal cards and I just got. So yeah, for E of X, and then we'll just say that D of X is just both of these being true, like I wrote before. So D of X. So that means D of C. So yeah, existential instantiation. So that is that part. Now we have sentence 1. Convertible car is fun to drive. So E of X, C, and D, or F, my bad. Sentence 2 says Isaac's car is not a convertible, so not C of, we'll use D this time just to avoid confusion. So then we have our thesis, which says, therefore, Isaac's car is not fun to drive. Therefore, F of D. So, oh, fuck. Unplug my tablet. All right. So, yeah. So yeah, we have our instantiation part, so we know that this first sentence checks out. So now we just need to look at the formula. So C is our P, F is our Q, this is not P, and this is not Q. Does that exist anywhere? Oh wait, this is and, right? Yeah, so P and Q.
no, it doesn't.
No, it does not. As P or Q, but that's not what it's asking. It's asking for P and Q.
But the
So no,
statement is false.
the statement is false.
Okay.
Oops. There we go. Damn, why does it keep on unplugging? No friction. All right. And then if you think about it logically, a convertible car is fun to drive. Yeah, that doesn't make sense. You could just have like a 1980, the retro cars. People like the antiques.
Yeah.
Shit like that. But that's obviously not like enough proof. So, but just to make sure you know you're in the right path. So yeah, B is false. And then I guess, does anyone need me to do A since we're here?
I'll get me as well.
Yeah, fuck, I might as well. So what do we have? Everyone enrolled at a university has lived in a dorm. So E of X. X is at uni. And what's it called? D of X. X has lived in dorm. Was our first sentence, everyone enrolled in a university has lived in a dorm. Mia has never lived in a dorm. Therefore, Mia is not enrolled in a university. So what is it? Yeah, universal instantiation? Yep. And then is this a formula? So E is P, D is Q. You get the idea. Does this exist anywhere?
Yeah.
Yes, it does. Modus tonens. So this is a true statement. Everyone? Universal instantiation and then modus tonens.
Yeah. Makes sense to me.
Cool. So yeah,
Appreciate
A true, B false, C false, D true. Coolio.
I'll be back.
All right. I think we can move on to a different section. This, at least for the sake of time, I have class in an hour. Back here. All right. So what was next on our list? I don't have pen perms. Yeah, I don't have pen perms, so I can't pin anything. Oh yeah, he already got it. All right, cool. Where did that guy post the thing again? Was it in general? No, session planning. There she is. Okay. Basic proof techniques. Yeah, let's hit those. Introduction to proofs.
If I recall correctly, he mentioned that we should always initialize our proofs with direct thread unless stated otherwise.
What do you mean initialize? Oh yeah,
Like
yeah.
your
I mean,
first,
I don't.
your first
No, it doesn't matter.
initialize.
If they don't tell you what to do, you can do whatever you want. I'm pretty sure.
Okay.
Yeah, I'm pretty sure. Yeah, like over here they tell you, but then if they don't, it's just whichever's easier. But usually, whenever they don't tell you, like it's pretty like obvious which one you're supposed to use because it's like significantly easier to use one than the other. That's yeah. That's how most of them work. All right, so let's look at a good one. 7. Use a disject proof to show that every odd integer is the difference of two squares. Huh. What? Oh, okay. That's kind of crazy. To show that the integer.
What are we doing?
I'm looking at 7. I'm trying to see how you would even start with that. Oh, they want us to use induction? No, we're not there yet. We don't want to do that yet.
Oh, like for example, like 5 is the difference between 16 and 9. No, wait. What am I even talking?
Yeah.
Like 9 and 4, I guess.
Yeah, that's 5.
Okay.
Yeah, no, yeah, you have to prove this with induction. Whenever you see a k plus 1, it's probably induction because that's what induction is. Just proving it for one number and then prove it for the next number, and then that's how it works for every number. So let's do 27. 27. I like these whenever you're just using the definition of numbers. So use a proof by contradiction to show that there is no rational number r for which r cubed plus r plus 1 equals 0. Assume that r is a or b root and a, b are integers. Yeah. All right, cool. Everyone ready for number 7?
I think.
Hold on, let me do this real quick. I mean, yeah, y'all can start whenever y'all want, but when the 5 minutes is up, that's when I'm gonna start going.
Contradictions where you prove the hypothesis wrong, right?
Nah, contradiction is where you negate the statement, show that the negation is false, and then use that to prove that the normal statement is true.
Oh.
But you can only do that if it's like it's either this or that. Like you can prove that a number is even because it's either even or odd by contradiction. So if you're trying to say that like a formula is always be even, you could be like, I assume it's odd. You prove that that's false, and then like, since it can never be odd, it can only be even. Therefore, I'm right. Type beat. That's contradiction.
I see what you mean.
Yeah. All right. Cool. Starting the 5 minutes now. Actually, I'll give us 7 minutes. 7 minutes now. Also, don't be afraid to write English when you're doing proofs. You don't have to just use math. You can like explain what you're doing too. You can even draw if you want. Like when we get to sets, you can literally draw the set for an answer.
Venn diagrams?
Oh yeah, Venn diagram. My bad. Yeah.
Didn't he say not to do that?
Oh, he did? Oh shit. Never mind.
Yeah, he
Right.
said you can't use the Venn diagrams as a proof. You have to, like, if you want to explain it better, you can make it, but You still have to write words for
Oh,
the
okay. All right.
but I get what you mean.
He just emailed us.
What do you say?
The answer yes. He's gonna provide inference rules and logical equivalences will be given in the exam.
He said he will provide them.
Yeah, again, the exam will be closed to everything, no books, no computer, cell phones, or any device. I will see you all tomorrow morning.
Okay.
Oh, it's at 8:30, motherfucker.
I think no.
Ugh.
Well, I think that's a W, right? The fact that he's providing that. That's something good that we have forward in our favor, I guess.
Oh, I'm stuck.
I almost got it. Give me like 2 more minutes. Yeah, these kind of proofs really require like out of the box thinking. That's the hardest part. Like it's really not intuitive, like ever.
Yeah,
You
yeah.
have to like do some really random shit. Like you have to be like, I'm gonna do something completely crazy and hopefully it works.
Yeah, I was
Or
trying
like
to
just
follow the hints and it doesn't lead me anywhere.
no, yeah. Just give me 1 sec. I'm on my explanation.
Oh, Blackout, you going to the comp art class today?
Oh,
Yeah.
are we? Are we actually boycotting?
I feel like there's no point for me because
I go over there just to play games, though. It's my Zen era, my Zen area.
bro, I can't even do that. I have literally 3 tests this week. I have this test, I have another test, and then I have my another test after that too. Back to
Damn, you
back.
got trolled.
Yeah, I got fucked really hard this week just because
Yeah.
of that storm or the winter freeze. God damn. I'm just lucky I don't have work this week. Or else I would have been royally screwed.
Oh no, yeah, you wouldn't. God. Yeah, our schedule's really fucked. That's crazy.
Yeah.
All right, well, I have an answer. The only problem is I did kind of stretch. I don't even know if you can call it a stretch. It's like a miniature reach that I did on my last part that you're just gonna like I'm sure you can prove it. It's just that I don't know what the proof is, but like you'll know what I'm talking about. All right. Is everyone done though? Is everyone ready for me to explain my solution? Jesus Christ.
I am. I've been stuck.
Oh, my whole computer is just fucking going crazy.
Oh, jeez.
All right, cool.
Will, fix it. We're computer scientists. Oh, God.
All right. So, all right, hold on. Let me get the question up here. Which one are we doing again? 27?
Mm-hmm.
All right, 27. Oops, there you go. Number 27, right? So it wants us to say that there is no r can. So for this for this expression, r plus cubed plus r plus 1 equals 0 to be true, r cannot be a rational number. That is what it is telling us, and it wants us to prove this through contradiction. So what we're going to do is we're going to be like, say, scroll down, please. Say that r is a rational number. Let's see if our above statement can be true. So if we plug in r into our statement, we're going to get a over b cubed plus a over b plus 1 equals 0. So this is where the not mental gymnastics, but out of the box thinking comes from, because now you have an equation and you have to find some way to, I guess you can think of it as checkmate the equation. So be like, I'm going to rearrange this equation and put it into a way where that no matter what you plug in for a or b, it's never going to be true. Like this equation will, like, you can just see it, like just look at it. You can plug in any number you want. It's super obvious. It's never going to be true. You have to find some way to rearrange this equation like that. And hold on, let me just give myself more space because OneNote likes to be a bitch with that. So we need to find some way to rearrange this equation into a way that'll just make it look completely wrong. So let's just start off by simplifying it a little bit. So let's do a cubed over b cubed plus a over b plus 1 is equal to 0. And then from here, I was kind of playing around a little bit and I was like, let's just move the 1 to the other side. Let's just do a cubed plus b cubed plus a over b is equal to -1. What else can we do? So we have a negative number right here. And what's something that just completely hates negative numbers? Like you're never going to get a negative number out of it. Squares. Well, we have a cube here. We have a cube here. We can factor this out. You know, we know our exponential properties. This is just a squared b squared times a over b plus a over b is equal to -1. Well, look at that. Factors. Let's do some of that. Let's do a squared or a over b. What? A over b. This is times a squared over b squared plus 1 is equal to -1. All right. So we have a new formula completely equivalent to the one that we had before. Let's see, is there some way that we can kind of look at this and be like, there's just no way that any of this is going to give us -1. So if we look at this middle part, and this is the part where you can start writing in English, so let me do that. If we look at that middle part, we have a squared over b squared. Okay, actually, I forgot to do something. B cannot be equal to 0, obviously, because it's the denominator. So we have a squared over b squared plus 1 is equal to -1. So looking at that middle part, we're going to be like, a squared over b squared, since we're squaring the numbers, they're always going to be positive, which means a squared over b squared would always be positive. And since we're adding 1, it's always going to be positive. And the key point is it's going to be a positive number greater than 1 because of the plus 1. So we can look at this and be like, since we know that this middle part, it will always, just fucking put X, always be positive, all that really matters is this part to bring us here to -1. Well, if we look at it, we can be like, this is going to be a positive number greater than 1. And this is just going to multiply that number. Well, you really can't, or actually, let me put it like this. This is kind of the reach part that I was talking about, because this number, if you multiply it by this, you're going to get a number that's still greater than 1, because if a is greater than b, then you know that this is just going to increase this number. It's already greater than 1, so there's no way in hell it's going to make it to -1. And if a is less than b, then this is going to be some fraction. So it's going to be like, so if we say that a is equal to 1 and b is equal to fucking 20. So we'll have 1 over 20 times 1 over 4,000 plus 1 is equal to -1. This, once again, is a fucking positive number, so it's like, 401 over 4? and then we're going to multiply or essentially divide it by 20. So we do that instead. So divide this by 20. Well, when we divide it by 20, we're going to, get rid of this numerator, but that doesn't really divide evenly. So we know that this is going to be a number that cannot be 1 because it's not going to divide evenly. It's going to give us some fraction. So it's definitely not going to be a whole number, and it's definitely not going to be negative because this is also a positive number. So if we were to say that a was -1, this would still be that, and this would now be negative. This would be negative. Well, yeah, it's going to be a negative number, but once again, it's not going to divide cleanly. And that's going to be like the case for most numbers. Like I checked like 5 or 6 numbers, and that's usually the case. It's usually just that you can't divide this number evenly by this number, which means that you're going to get some fraction. There's going to be a fraction over a whole number. And since we know that it's not going to be equal because this is a fraction, this is a whole number, it's never going to yield 1. And it can be negative sometimes, but it won't be negative unless this is negative too. But this is the main part, that you're going to get a fraction over a whole number. So that for sure, 100% is not going to be equal because of the decimal point. So now we can come down and say, all right, so we have this formula, a over b, a squared times b squared plus 1 is equal to -1. Based on everything I said. So what did I say? I said, what's it called? A squared. I'll just write it down. Sorry if my handwriting is super shit. So a squared over b squared, always positive. A squared over b squared plus 1, always positive and greater than 1. And since all that matters is a times b, we just look at the different cases. So the different cases are that a is negative, or a over b is negative, or it's positive. Well, if it's positive, this is always going to work because you're never going to get a negative number. So we don't need to worry about that. So all we need to do is worry about if a is a negative number whose absolute value is less than b, or if a is a negative number whose absolute value is greater than b. So for case 1, I already told y'all, or actually no, for case 2, I already told y'all this is just going to increase this number past 1. So that's just going to go, greater than -1 always. So this is our main little spiffy case. But as I showed y'all, for this case, you're always going to end up with a fraction over a whole number, for your ending fraction with a whole number, and that's no way it's going to be equal to -1 because once again, this fraction is going to have a decimal point, and this whole number won't. So it's going to be probably 1.00056, some shit like that, but not exactly -1. So based on that, this equation is not true. You cannot express this as a whole number, and therefore our original hypothesis is true.
Okay.
Anyone lost? Did I lose anyone somewhere? Look at general TC.
Well, it seems everyone's good.
All right. So everyone gets my logic. Everyone sees how I got to that conclusion.
Yeah, I
All
think
right, cool.
that's good.
Yeah,
And
this
if
was
anybody
a pretty fun problem, I'd say.
Go ahead. Yeah, confusing a bit at the start.
Yeah.
So I have to do the homework and the rework.
Oh fuck! Picture? Anyone? Picture? Does someone want a picture? Or actually, I think I can copy this all and
Yeah.
drop it in because you can't take a picture of all of it. Fuck me. All right. I guess we're recording it, right? So it doesn't even matter.
Yeah, I think we'll be fine. But
Yeah. But let me just do this. There you go. All right. There's the work for that. Now I can get rid of it. Fuck. Keep on forgetting about that.
isn't there
All
a
right, cool
clear
beans.
button?
Right. Let's see if there's another interesting question waiting for us. Oh yeah, we can. I mean, it's really just like that's the thing with proofs. There's a lot of ways to do it. So what they get may not necessarily be what I like the route I took, but like as long as it's like you can follow it and it's like it makes sense logically, then you know you're right. That's the thing with proofs. So like their answer will give you like the staple answer, but there's multiple ways because and like, as for the way I just proved you to, what was this section 1? No, this is section like 2 something, right?
2 point.
Oh no, 1.7. Okay, 1.7. This was question. What question was this again? Anyone remember? 27.
27, I think.
So yeah, here's one way they do it. So yeah, all of this up down to there.
Jeez.
So suppose by way of contradiction that a over b is a rational root where a and b are integers and this fraction is in lowest terms. That is, a and b have no common divisor greater. Oh, so they even took it a step further with that. Yeah, if you do this, and then my proof works even better because I don't know. I was kind of iffy. Like if you had a bunch of even numbers, and maybe you could like divide it somewhere, and then you'd able to get one. Luckily, but nah, I don't think so. So. Oh wait, no, actually. Yeah, no, since you need to divide B, or that's only if A is oh yeah, no, yeah, my proof works. There's just a lot of things I need to explain. Or cases y'all need to explain. But no, I think for the most part it works. Yeah, it does work, it works. Alright. So suppose by way of contradiction A, B fraction root, A, B are integers, and this fraction is in lowest terms. Plug this proposed root into the equation, multiply through and obtain B. Yeah, that's the way I did the first time, but then I got stuck, so I ran back. That's something else y'all need to get into the habit of doing. Whenever you get stuck, don't be afraid to just erase everything and go back to square one. Because that's usually what it's gonna happen. You're gonna be like, I don't know where to go from here, and then just like try a different, more odd route, see what you get. Just keep on fucking with the equation.
Yeah.
So if A and B are both odd, then the left hand side is the sum of 3 odd numbers, and therefore must be odd. If A is odd and B is even, then the left-hand side is odd, even, even, which is again odd. Similarly, if A is odd and B is even, even, odd, which is again odd, because the fraction A, B is in simplest form, terms it cannot happen that both A and B are even, thus in all cases left-hand side. So yeah, this is, yeah. So they didn't do any arithmetic in this proof. They literally just told you, here's this formula, think about numbers. When you think about them, my proof makes sense, so I'm right. And then mine was like, let me like run through the math of it and like use some more commonly known properties of numbers, like how squares are always positive, and then just run through the test cases that could give you the answer, but you know they don't. Shit like that. So yeah, multiple ways to do proofs. That's just again the hardest part of proofs. You can't really. There's no shining answer. You just have to fuck around until you get it.
Mm-hmm.
So let's do another one. That was actually kind of fun.
Not for me. I got stuck instantly.
Yeah. No, yeah, I got stuck too. It's just it's just the running back part.
Yeah. No, in the middle of it, I got an email about someone cheating, and I was checking if they gave me a 0 in case.
Oh shit, that's scary.
Yeah.
Oh yeah, I want to do shit like this. That shit's really fun. Proof method and strategy. What the fuck? This is the most. Oh my god, 21 res, so easy. Anyways, harmonic mean. Does anyone want me to go over 21 just in case? This is something that you need to just have like completely memorized. Like no matter what you do, you need to know this formula.
Yeah,
But
let's do
it's basically just so it's saying n is the sum of k minus 1 plus. So you literally just add these numbers. You're gonna get 2k plus 1, which is the definition of an odd number. Like literally.
Oh. Yeah.
So yeah, let me write that down. This is like super important. Like we're probably gonna get a question like that. I bet like $50. We got a question that involves you to know this identity. So X is an int. X is even equals X equals 2K. X, all right, let me do this instead. X is odd, therefore X is equal to 2K plus 1. Super important to know that. Because it's going to ask you shit. And then also, what's it called? X is a rational number. X is equal to A over B. X is, or A is int, B is int. Not fraction, or not decimal. Fuck. Not decimal. It's an int. It's an int. These are super important to know.
Yeah, that's where I was wondering how you could say that the fraction is just whole numbers. I see what you mean.
Yeah, that's the definition of a fraction. It's just an integer divided by an integer.
See.
Or root. Or shit like that. You get the point. A whole number. Whole number, I should say. Actually, no, it can be negative. Root. So yeah. No decimal point. It has to be a whole number, or it's just say an integer, because it can be 0 or, and then b is not equal to 0. It cannot be equal to 0. Cool. So yeah, you got that? All right, cool.
Yeah, I took a screenshot of it.
So super important formulas. So yeah, for that question, saying n is the sum of what, k plus 1 and then, or k minus 2, k plus 3, shit like that. So you would literally just, can you fucking erase, bro? Oh, yeah, I have to use delete. Okay. There we go. So n is equal to k plus, oh no, k minus 2 of that. Can I just undo? Whatever. K minus 2 plus k plus 3. Simple algebra 2k plus 1. Well, wouldn't you look at that? It's odd. As stated. Oh, fuck. Prove that if n is an odd integer. Yep, as you said. Easy question. All right, cool. But yeah, know those formulas. Prove that given a real number x, there exist unique numbers n and epsilon such that n minus epsilon, or x is equal to n minus epsilon, n is an integer, and epsilon is less than 1. That given a real number x, there exists unique numbers.
Epsilon's between 0 and 1.
Oh, wait, what? This is weird. What? How do you explain this? Wait, yeah, how do you explain this? I don't, because this is literally just like, so n is going to be your whole base, and then epsilon is going to give you a decimal component. That's literally all it is.
Oh, yeah.
Yeah, because it's going to be, it can't be 1, but it can be 0. So if you have like 14 minus 0, x is just 14. But it's like 0.5, then x is just 13.5, but it's a real number. Yeah, how do you, it's like 2 sentences. I don't know. Yeah, I would just write something like, just use your intuition for this one. There's no math. This is just, yeah. Verify, no, plug and chug, I don't give a fuck. Verify the 3x plus 1 conjecture? Oh, I don't even know what that is. Oh, why are these questions so weird? Prove that n squared plus 1 is greater than when n is a positive integer. I mean, you could just do all of them, but I don't think they want us to do that. I think, yeah, there's a way of doing that. I remember learning that at some point. Whenever you have like a range of numbers, you just do like, what's it called? Let's just stick to 1.7. 1.8 is kind of weird. Prove that m squared equals n squared if and only n is equal to n, or m is, that's just the definition of a square number. Just a negative n times negative n is going to be equal to n squared. Basically, where a Oh wait, I can't even look at the answer. Oh yeah, we can look at the. Oh yeah, we did. Prove that at least one of the real numbers, A1, is greater than or equal to the average of. Oh, this fucking problem, bro. I remember this shit. Yeah, 41. Okay, I fucking remember this problem. This fucking is so weird. All right, cool. Let's do 10 minutes for this one. This is kind of a nutty problem.
Okay.
All right, cool. Yeah. So basically, you're given a set of numbers, and prove that at least one of those numbers is less than or equal to the average of the set of numbers. Oh, wait, no, greater than. Oh, it's greater than.
Oh.
Yeah. Okay. Yeah.
Wait,
10 minutes for this one. This one is really weird. I don't exactly remember the proof we did, but I'm gonna try to figure it out again. But
wait,
yeah,
all we're
10
trying to
minutes.
figure out is that the number is greater than the
So
average.
no. So basically, you have a set of numbers. So say you have a set of 5 numbers, right?
Uh-huh.
1, 2, 3, 4, 5. Prove that at least one of those numbers. So if you take the average of 1, 2, 3, 4, 5, you're going to get another number. Prove that at least one of the numbers in the set of 1, 2, 3, 4, 5 will be greater than that number you got for the average.
One, the number at the end will always be greater. So if
Prove that. How do you know that? Yeah, that's the hardest part. Anyone can say the conclusion, but how did you get there? That's the hard part.
Okay.
All right. So 10 minutes. 3, 2, 1, go. For this question, I think we should have gone over sets.
After this question, we'll go over sets.
Yeah, I know. Before we tackled this problem, we should have gone over sets because we need to do some set operations and stuff like that. I don't remember if that's how. Actually, let's. I mean, I'm stuck, but does anyone? People still going?
I think I got something, but I didn't do sets at all. I just did it as words. Didn't do any arithmetic.
All right. We have like a minute 30 left, and then I'll go get into.
Yeah, I'll probably have to get off soon
Yes.
for class at 6. Actually, 7, but I want to try get started on the rework for the exam.
Oh yeah, they're doing that right now, aren't they?
They
At,
were.
the library.
They were. I think they left. I'm not sure.
Yeah, probably.
They're planning to do one on Thursday too. Probably over.
Oh,
Discord.
yeah, that's better.
Yeah.
Have more time. We made the bathroom real quick.
Mhm.
All right, well, time's up, so let's go check the answers. What question was it again?
I think it was 18.
It's the odd numbers, bro.
Oh,
Let me see. It's 41.
41.
Oops, wrong. What section was that again? 1.7.
That 1.7, 1.8, because I think this is.
Oh, it was 1.7. It was 1.7.
Yeah.
E41. We will give a proof by contradiction. I knew it. Suppose that A. Or I don't know if y'all can read this. Suppose that A, the set are less than A, where A is the average of these numbers. Then A with A is less than NA. Yeah. Divide by.
Both sides by n.
Wait, what?
So. I
Oh
don't know.
yeah. Dividing both sides by n shows that A is equal to A,
Less than a.
which is a contradiction. Yeah, there she is. I was not getting there, to be honest. I was using this as in there exists a number that. Yeah, you should have done a proof by contradiction. I knew it was a proof by contradiction. I don't know why I didn't go with that.
That's actually
But
kind
yeah.
of similar to what I did.
Oh wow.
What'd you do?
I set the set of the numbers equal to a, and then I set the set of that divided by n less than the average of a.
Yeah.
Try to work it out that way. I didn't quite get to the end though, because I couldn't figure out where to go.
That actually. Mm.
Well, I think I'm gonna go. I have to do the.
Wait, what? Oh, yeah. Okay, yeah.
I have to get to other stuff. That's the
Yeah, after that, I'm probably gonna hop off after this one too.
I appreciate the
Uh,
help though.
Yeah, I'll probably pick up at like 10 because I'm gonna do like my physics homework at like 8. Or actually, I guess since I'm not going to class, I can just do it now.
Yeah, that's what I mean. I was
Yeah,
gonna do the rework right now, and then I have class right after. So
yeah. Okay, then I can try to do the some more probably at like 8 or 9, and then I need to sleep early because the test is early, so
yeah,
probably go to bed at like 10. All right. But yeah. So I guess that was part 1. Tomorrow we'll do sets and induction, and then, or not tomorrow, later tonight we'll do sets and induction. So I guess have a good meal then. I'll see y'all in 5 hours
yeah.
or 4 hours.
Later, y'all.
All right, later.
Later.
Thanks for the help.
OBS. It's just blank. Like it, and you've got your backgrounds